So welcome back, everyone. So this is module 8. This is the last module of the series around machinery safety. So in this module, we are going to explore around safe systems of work and lockout, tag out. But before they do that, it's really important for us to step back and talk about the issue that we have here is that we only need to use safe systems of work of things like lockout, tag out, because we're not able to directly influence the presence of a hazard on that machine. And what I constantly see with machinery is that when I look at how that risk assessment was undertaken by that organization, there was nothing there to tell me why they weren't able to apply a higher order control. And if we think about that, if I think about evidence of what was reasonably practicable, if we go back to what the Act talks about, it says the most important thing to consider is the likelihood of the risk causing harm, the consequence of that harm from being exposed to that risk, and the knowledge about the risk and the means of mitigating it. And less important is the availability and the cost. So knowledge. The AS/NZS 4024 series is deemed to be knowledge. And that is what the regulator will face on. We'll focus on when it comes to that machine. Your risk assessment should have looked at the likelihood and the consequence of that risk. And what I'd like to share with you is that when I look at the regulations around the high hazard industries, and if I look at a joint Australia-New Zealand standard called HB 205, there is already a layout that helps people understand around that good practice for documenting that risk. And I'm just going to share that with you. And this document is also going to be made available to you as part of the handout. Now, none of this should come as a surprise. And what they're saying here is that you obviously need to understand, the hazards identified, the results of your process, all those things are important. But they're also saying that you need to show evidence of how you engaged, how you communicated, and how you consulted both with internal stakeholders and external stakeholders. So for instance, to me, internal would be workers that have to use the machine, workers that have to set the machine up, workers that have to clean the machine, and the engineers that need to maintain it, or the workers that need to clear jams. Your external stakeholders are the people that supply the equipment to you or perform maintenance on that equipment. And if you've had to seek specialist advice, for instance, you've had to do some form of noise assessment or lighting assessment or some form of machinery assessment, you need to basically have that evidence of who you engaged and its purpose. And what I like in particular about this standard is it says that you must have documented reasons for not applying higher order controls. I think that is super powerful, because how often do you see it where we think that it's just too hard and all we simply do is put in place some form of procedure or put in some form of sign or put in some type of SOP or JSA to make up for that. And these standards, and also if you look at the regulations from WorkSafe around high risk, say that is not acceptable. You have to say why you can't do it. And that requires a little bit of maturity. So that's the standard there. It's been around since 2017. I like it, it's consistent, and I've given you that one page around that. But if I think about a safe system of work, quite often there is a lot of confusion about what is a safe system of work when it comes to machinery. And here is the definition from WorkSafe. And all we're saying here, it's some form of formal work procedure developed after that systematic examination of a task to identify all the hazards. And that its purpose is to only define safe ways to work when hazards cannot be completely eliminated or isolated. So link that back to our previous slide. If you can't put in a higher order control, then you need to put in place a relevant safe system of work. And that need or level of safe system of work will come down to the consequence that the hazard can form. And if I look here, if I look at safe systems of work, on this diagram, you can see here that I say that the safe system of work moves from one that is more informal to formal as the risk increases. So a work instruction would be the absolute minimum. Now, when you purchase machinery, the supplier or the designer of that machine should provide you with an operator guide. And that operator guide should talk about how the machine should be used based on its design. You can uplift that, build that into a work instruction if you want, remembering that your work instructions need to take into account the needs of the workers, including their literacy and numeracy needs. And so safe systems work, they increase, they go from work instructions to pre-start, to safe operating procedures, to job safety analysis, to safe work method statements, and probably the most formal safe system of work that's out there is a permit to work. So depending on the nature of the risk, the fact that you can't put in those isolation or those engineering controls. So say for instance, if you put an engineering control in, basically work instruction will be sufficient. If you can't put in an engineering control and you're having to rely on behavior, you very much want to have those SOPs that exist that you're training people in for normal work. But if it's not normal work, say for instance, where engineers are having to come in and make repairs or remove guards, then that is where you want to have some form of job safety analysis. Remembering a JSA is basically supposed to be a pre-planning tool, and it's supposed to be a systematic breakdown of what we're going to be exposed to. Do we do that well? No. I have to be blunt, we don't do it well. Why don't we do it well? In many cases, those things are developed in isolation to how people actually do the work. My advice to anyone, engage with workers that do the work and understand how they do it. Compare that to what the manufacturer or the designer expects, and then have a chat, consult with the guys around that. Now, those things are really important. And use the language that the workers use, not necessarily the language that the designer used. And I personally see an overuse of lockout and tagout as a form of isolation, when in actual fact, it is simply an isolation procedure. It is not physical isolation. And the reason it's not physical isolation is because it requires a competent worker to be able to understand where the energy points are on that machine, how to successfully lock out that machine and complete that process. So to use lockout tagout, you must have a machine procedure. So you've got to have that safe system of work. You've got to make sure that your workers are trained and assessed being able to complete that. And you've got to provide some supervision to ensure isolation is undertaken successfully. So there needs to be a strong level of monitoring. And when I look at lockout tagout, there are it's made up of these 8 elements. And when I explore those 8 elements with the organization and with the people that do that, I typically find some of these things are actually missing. So why 8 things? Well, I would suggest to you that these 8 elements of the process, as they're trying to actually slow down that person to give them that capacity to think. The downside to this, if that job, say for instance, that job is cleaning a machine, and that cleaning only takes 10 minutes, but to put the lockout tag out in takes 20 minutes. If the organization doesn't provide for that space, for that work to be done based around the system need and the worker need, will people take what you guys say shortcuts versus what I would say is that they're trying to be as effective and efficient as possible? And the one I see most that is missed is the final one, being test and verified. So how does a person test and verify that all energy sources have been removed? Remembering those energy sources are not just power. Those energy sources could also be pneumatic, and those energy sources could also be anything under pressure, and it could also be stored energy at the same time. And with that lockout tag out, you actually need some equipment to go with that. And these are some examples of the typical types of equipment that can be provided. So I see it quite often, if you have machinery that can be moved around and it has a standard 3-pin plug, might be a 15-amp plug, for instance, you actually need a cap that can go on that plug, because that machine can be moved anywhere and plugged in. So this whole idea of these shrouds or locks is they can actually stop the machine from being used when it's particularly in its portable. And obviously when we talk about multiple locks, that is where basically no one person can remove the lock and restart the machine. So where you've got a really, really high risk situation, that is where you want to have the supervisor's lock on there, and you want to have the person working on the machine having their lock. So it requires those 2 things to happen simultaneously. Does that make lockout tagger error-free? No, it does not, because you are still 100% reliable on those workers knowing and being willing to follow that procedure and perform those 8 steps 100% of the time. I personally don't think that is possible. So what's the alternative? Well, if I go back to it, I always ask the question of people, what are your controls trying to influence? And in this case, if the control, so if I think about engineering and isolation, those controls are purely focused on the hazard itself. Anything that is behavioral based or administrative based or is PPE based, those things require the worker to be an active participant in that. And the worker looking at that worker needs to work out, and this is where the training comes in, are they performing an action? Are they having to follow a process, or are they having to achieve a goal? Now, an action can come from recall, which is what we do with training. A process requires thinking. So a process requires someone to be able to recall the system that they use and follow that process. And typically, we use things like checklists to support that. And the goal is the optimum outcome. So if I was to explore that with lockout tagout in particular, and I'm making these diagrams available because it's a great way for you to do that. So we have here we have, in this case, we have a hazard. In this case, it's some sort of sharp cutting disc. And at the moment, if the workers have to clear a jam, they access the danger zone of the machine using a gate. The gate is an action. They then have to follow the lockout procedure, which is a process. They then have to fit the padlock to the isolation device, which is an action. Fit the tag to the isolation device, which is an action. And all three of those things have to be done perfectly for the goal of isolation to exist. Do we honestly believe that that happens every single time? So let me show you an alternative to that with machinery. So in this case, we have the same hazard, we have the gate, but in this situation, we have fitted a safeguarding device called a captive key. And the way the captive key works is that when the key is removed, so the gate can only be opened by the key being turned and the key being removed. When the key is removed, it activates a shutdown to that machine. So it is a machinery-based isolation. And whilst that key is with that person, that machine cannot be restarted because it requires the key for the gate to be closed, for the key to be put back in, and for the key to be moved into the on position. And at that point, the operator can go to the control panel and restart the machine. So in this case, all that process, all that isolation control is all based on an action. So the successful outcome is based purely on the gate being opened to eliminate the risk of the hazard by removing energy. That approach is how you can reduce the human error component or the effectiveness or the efficiency trade-off that happens in that space. Questions?
Yeah, I got it.
How'd you find it, Wes?
Yeah, no, it's pretty good. Thank you very much. I've got two questions.
Sure.
Talking about the previous example, that example with the gate.
Yeah.
I totally agree and understand all of that, but that's making the assumption that from a normal behavior, someone will use the gate as normal and not jump over or climb through or climb under.
So once again, the machinery safety standards,
yeah,
basically the design standards show you what those gates should be made of, what their dimensions should be, and their heights.
Okay.
Okay, because there's a difference between unintentional and intentional access.
Yeah.
So the gate design, so all these things, like it's no different with the guarding design, they are there for what we call unintentional access. If someone wants to get the gas axe out, if someone wants to go and get a cherry picker and defeat that purpose, that is shifting it from being unintentional to intentional.
Okay, thank you.
You've seen barriers on the motorway, people can still climb over them.
Yeah.
Takes a lot of effort.
Yeah. One other question, this is more like a question for you and your experience visiting various sites. Thinking about LOTO, and especially with an organization that potentially has the overuse of LOTO on equipment or systems, have you seen it where LOTO has been applied can actually cause or have an indirect cause to different the risks or place the actual person in even more?
Yes. Absolutely. I mean, LOTO by its nature should not be used for routine work. LOTO is for non-routine work. So if a person is having to access a danger zone multiple times per day, at some stage they're going to bypass the LOTO system because nothing's ever gone wrong yet. So lockout tagout is really important for things like repairs and maintenance. And the lockout tagout, you actually may see some organizations actually use it as a permitted activity. And that permitted activity is actually linked to a JSA that the engineers have completed. That is where you get a more formal system of work. But what I see is that LOTO is being used frequently for normal operations, and that is not its intention. And that's where you get risk, because I ask people, what are you isolating for the machine? Seldom can they tell me.
No, okay. No, thanks for that. No, I was also
I love them to tell me I'm doing this because that machine can drop that down, and that dropping down can kill me. I love them to tell me that. But they've never seen it do that. So how would they know? And LOTO doesn't say that either.
So part two of that question would be then, have you ever seen equipment properly locked and tagged out, but because it's part of a system, it poses more risk, or could pose other risks?
Well, no control should introduce a higher risk than what it's trying to solve.
No, I understand.
Okay.
I was thinking of
somebody
let's lock this piece out, but they forget that it's part of a chain or part of a system.
Have I seen it? Absolutely. And that is because they haven't looked at the knock-on effect. So I see that really often with conveyor systems, where you might have multiple conveyors that form a system. And initiating an emergency response on one conveyor allows a buildup of material on another conveyor.
Correct.
That is poor risk assessment.
Okay.
Because those things are the things that you must take into account. Because an emergency stop cannot introduce more risk. The problem that I see is that people use emergency stops as a process stop.
No, I agree.
Which is not its purpose.
No, that's basically it from my end. So I'm not sure.
Thank you.
I'm not sure if Victoria's got any questions. I'm sorry if I took a lot of time.
No, we're good. Would you like to ask something, Victoria? This is your time to shine. No pressure from me.
Well, it seems like this is it for today. So I just want to take this opportunity, Brent, then just to thank you for for your time investment with the 8 webinars. We really appreciate it. We've also been sharing them on our YouTube channel, and we've got some really good views out of it. So, and I have some feedback as well that they've, from individuals that said they really love the webinar series. So, we do appreciate your investment here, and even if it's just someone like Victoria, or it's 20 people on here, like we've had as well, I do feel like that it has a positive benefit and impact within individuals, because what I like about these webinars are they really tactical to that point as well, and because you get a lot of webinars are just floating very high and don't give you practical advice, where this is really practical from a tactical from that aspect, and I feel like a lot of individuals can learn from this.
Look, thank you. And look, and I've enjoyed being part of that process as well, Wes, because at the end of the day, if we can build more knowledge and understanding, we can actually design better machines. If we can design better machines, we have to less worry about the whole nature of being human.
No, I totally agree. Then
Thank
lastly, guys, I will share the link as soon as it's up and running, and I will also share the handouts as Brent has mentioned a little bit earlier on via email. Thank you yet again, guys, for coming along. This comes to the close of the series of machine safety. Yet again, thank you very much, Brent, for your time. We really appreciate it. And till next time, take care, be safe, and have a good day.
you.